In this video, we are going to work the following problem. We want to evaluate the integral. It's the integral from 0 to 2 of minus x cubed plus 4x squared minus 5x plus 3. All right, so the first thing that we need to do is to get an antiderivative of this polynomial here. We can see that it has 4 terms, right? These are separated by addition and subtraction. So we can use the sum and difference rules to find the antiderivative of each piece here, and then just add or subtract them back together. And that's what we need, right? We need an antiderivative of this function. So starting with the first term, I have a constant multiple rule, a negative 1, right, times x cubed. So the constant multiple rule says I can rewrite the constant and then multiply by an antiderivative of x cubed. Using the power rule, right, I would add 1 to the power and divide by the new power, which is the same as multiplying by 1 over the new power. So either x to the 4th over 4 times minus 1 or minus 1/4 x to the 4th as I've got it written here. All right, next up I would add the antiderivative of 4x squared. Again, using the constant multiple rule, I can rewrite that. I can just rewrite the constant, write 4, and then multiply by an antiderivative of x squared. Again, using the power rule, I would add 1 to the power, right, and divide by the new power. Next up, I would subtract off an antiderivative of 5x, right? Again, using the constant multiple rule, that can be rewritten as 1/2 x, or 5 times an antiderivative of x, right? Again, using the power rule. Remember, this is an understood 1 on the power, right? So I would add 1 to the power and divide by the new power here. And then finally, an antiderivative of 3 would just be an x, or 3x rather. And then I want to evaluate that from 0 to 2. And this symbol, right, just means just take this number and plug it in, and then take the 0 and plug it in. Okay. There's not too much simplifying to do here, but I strongly recommend for you to simplify the antiderivative as much as possible before you start plugging in the numbers. Otherwise, you're basically creating more work for yourself. Maybe not in this particular example, but in plenty of other examples, if you don't simplify, you'll basically have to kind of simplify twice after you plug in. So all right, so now I'm got my antiderivative as simple as possible, and I'm going to evaluate it at 2. So in other words, take this 2 and plug it in here. So I'd get negative 1/4 times 2 to the 4th plus 4/3 times 2 cubed minus 5/2 times 2 squared plus 3 times 2. And then I am going to subtract off what I get when I plug in the bottom number. So that's going to be 1/4 times 0 to the 4th plus 4/3 times 0 cubed minus 5/2 times 0 squared plus 3 times 0. All right, and then I am going to simplify all that out and come up with a number. All right, so 2 to the 4th power is 16. 2 cubed is 8. 2 squared is 4 plus 6. And now looking at what I have here, I've got this is going to come out to be 0, right? This is going to come out to be 0. This is going to come out to be 0. This is going to come out to be 0. So this whole second term is going to come out to be 0. Just, be a little bit careful about that. You'll find a lot of people will just kind of jump to the conclusion that because this is 0, when you plug it in, you get 0. That's true for a polynomial like we have, but there are plenty of functions that are not going to be that way. So just make sure that you don't jump to that conclusion too quickly. All right, keep simplifying. Here I have negative 1/4 times 16. That's going to give me negative 4 plus 32/3 minus, all right, here 2 would go into 4 2 times. All right, and then 2 times 5 would give us 10. All right, then if I add these things together, I am going to get, or the integers together, I have negative 14 plus 6, which would be negative 8. All right, and so now I need to add these two together, so I would get a common denominator. That common denominator is going to be 3, right? And so I would need to get the numerator here. I would need to multiply negative 8 by 3, so that's negative 24. All right, and now that I have a common denominator, negative 24 plus 32 is going to come out to be a positive 8. So the answer on this problem is positive 8/3.